In this video, I'd like to continue talking about finding the midpoint of two complex numbers. And in the previous video, we looked at a formula for finding the midpoint of the two complex numbers by essentially finding the average of the real parts and finding the average of the imaginary parts. So let me paste in that formula and then we can apply it to this problem. So for two complex numbers, z1 and z2, notice that to find the midpoint, or the real part of the midpoint, we find the average of the two real parts of these two complex numbers, and we add that to the average of the imaginary parts of these two complex numbers. And this here, if we plotted it on the complex plane, will be right in the middle of these 2 points. In fact, this formula is very similar to the formula for finding the midpoint between 2 points on the normal xy coordinate plane. So to apply this, we just need to recognize what the real parts are and what the imaginary parts are. We have that m, the midpoint of the two complex numbers, is equal to the average of the real parts. So we will take 2 and add it to -6 and divide that by 2. And then we will add the average of the imaginary parts. We can take 4 and add that to -3 and divide everything by 2 to find the average. And of course, the imaginary part is multiplied by I. Now we just need to simplify everything. 2 plus -6 is -4. We will cut that in half. And over here, 4 minus 3 is 1. So we have 1/2 times I, and this simplifies to -2. So the midpoint of these numbers is -2 plus 1/2 multiplied by I. And if we wanted, we could plot both of these points and visually confirm that this is in fact the midpoint. It will be right in the middle of those on our graph. And I encourage you to do that to check your work here. And let's do one more problem where in this problem, we have a plot of two complex numbers and we need to find the midpoint. And on the actual Khan Academy exercise, we will take a point and actually drag it to the midpoint, which should be somewhere in here. Though to confirm that, we will again use the formula. So let me paste that in once more. And we can start by rewriting each of these complex numbers in terms of their components. We have 1 for the real part of z1 and 6i for the imaginary component. And for z2, we can notice that it has a real part of -4 and an imaginary part of -3i. So to find this midpoint, we just need to find the average of the real parts, which will be 1 plus -4, or just 1 minus 4, and we'll divide by 2. And then we will add that to the average of the imaginary parts, which will be 6 plus -3, or 6 minus 3. We will divide that by 2 and multiply by I. So simplifying everything, 1 minus 4, that is -3, and we're dividing by 2. Here we have 6 minus 3, which is +3, divided by 2, multiplied by I. So 3/2, or 1.5. In both of these cases, we can now plot everything to find the actual midpoint. And if we go over to -3/2, that's right here for our real part, and we will go up to 3/2 for our imaginary part. So our midpoint should be right here, which visually speaking, you can confirm that this makes sense. So the way to check these is to actually plot the points and make sure that it is right in the middle of these. In fact, if you want, you can draw a line between the 2 points, and that midpoint should always be on the line and in the middle of it. In fact, it splits the line in half so that this section and this section here, these should be equal to each other.